Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. Hi, Dr. Zuhi here. So this is for the course of EPF3108 Mass and Energy Balance, and this time I'm going to talk about the units and dimensions. As food engineers, you are going to do a lot of calculation when it comes to units and dimensions, and because it is something you're going to deal for the daily life of your career life, and because of that, it is very important for you to know about the unit and dimension. And I believe you already learned it during the basic chemistry and physics in the school. However, let's just do some revisions about the unit and dimension. Dimension, as for definition, is something that can be measured, and we have a few basic dimension such as the length, the time, mass, and temperature. And also beside the basic dimension, we also have the derived dimension such as force. You can see here for the symbol of length, time, mass, and temperature, we have a specific symbol which is L, T, M, and T. For the derived dimension, we have is a combination of some of the basic dimension here. And for units, as for the definition, is the means of expressing the dimension. It's either for the length. It can be meter, it can be inch, it can be feet. For time, it can be second, it can be hours, and so on. So why it is very important for us to know about the unit and dimension? Because when we attach unit to any numbers or figures, it will diminish possibility of mistake in calculation. So it's really important for you to have some consistency in writing down the units of all your calculation in order for you to avoid any possibility of doing mistake. And it also will reduce some intermediate calculation and time in problem solving. And it's also a logical approach, because why, as engineer, you need to have logical approach to any kind of problem rather than remembering a formula or plugging number in it, and easy interpretation of the physical meaning of the numbers you use. For instance, like if we are talking about time, we have the unit of second, hours, minutes, and so on. We're talking about length, we have meters, we have feet, we have kilometers, and so on. So it's easy for us to do the interpretations. So this is the basic concept of units, where adding and subtracting is only possible if the units and of the quantity are the same. If the units are the same, so we can do the calculation of adding and addition and subtraction. For instance, like 5 kg plus 3 joule. One is in mass, this is mass, and this joule is the unit of energy. So can we solve this? The answer is no, we cannot solve this because the units are different. What about 5 kg plus 10 pounds? Can we solve this? This unit is the dimension for mass, and pounds is also a dimension for mass. So have the same dimension. However, can we solve it? Still no, because the units are different. However, we can still solve this by converting one of the unit. Either we convert kg to pound and then do the solution, or we convert pound to kg first before we can solve this problem. What about however, the situation is a bit different for multiplication and division, where we can solve the problem for multiplication and division. For instance, like this one, 3 Newton multiplied by 4 meters. Can we solve this? Yes, we can solve this, and the answer is 12 nanometer. Okay, 5 kilometers divided by 2 hours. Can we solve this? Yes, 2.5 kilometers per hour. And lastly, 7 kilometer per hour times 4 hours. Can we solve this? Yes, we can solve this. We just going to multiply it. It's 28, where the unit is in kilometer and hour, and another one is hour. So we can cancel this hour. So the final answer will be 28 kilometer. So that's why I mentioned before why we choose units as to check whether we have done proper calculation or not, because when we do this, we cancel out all the unit involved. We know at the end we're going to get the right answer. Okay, so for units, basically in this world we have two kind of unit. The first one is SI unit, and the second one is the English units. Most of the country nowadays, including Malaysia, we are using SI units as our standard units. Well, the SI unit is stand for System International de Unit. I think this is France. Is established as the standard units, a standard system, where for the basic units, this is also referring back to the dimension, the basic dimension that we already talked before, the length, mass, time, and temperature. So these are the basic unit for that dimension. For length, meter is the basic unit. For mass, we have kilogram. Time, we have second, and temperature, we have Kelvin. So if I give you any kind of question and ask you to convert all the units to be the basic SI unit, I mean you need to convert all the units to be either meter, kilogram, second, or Kelvin. And for the derived SI units such as energy, we have joule, force, Newton, power, watt, density, kilogram per cubic meters, velocity, acceleration, pressure, head capacity. These are some example of the derived SI unit based on the basic SI unit as been given here. And for SI unit, what make it special is because in order for you to convert within the same dimension, what you need to do is just easily move the decimal point to convert between the prefix or measurement of the unit. For instance, like if you have 1 meter, you want to change to centimeter, so what you need to do is just times 10 power of negative 2 millimeters, 10 power of negative 3 nano times 10 power of negative 9, and also it can be bigger. Kilometers, it's 10 power of 3, giga 10 power of 9, and so on. So this is a special features of SI unit if to compare with the English unit. So these are the American engineering units or English unit. The basic unit still the same. We have length, mass, force, time, and temperature, and these are the basic unit for it. For length is feet, pound, mass. For mass, force is pound force. You can see the different M and F here. And for time is second, temperature is degree Rankine. And the derived unit is the derivation of this basic unit. We have energy, power, density, and so on here. So for the American unit, well, actually it's a bit different if to compare with the SI unit, because for the American unit we don't have this prefix. So what we need to do, if you want to change from one unit to another, you need to have a conversion unit or conversion factor, and this is also can be used in order for you to convert a number in certain unit to another type of unit. For instance, American unit to SI unit. So this conversion factor, normally we already put it in a proper table. You can just refer to which dimension you want to convert and just see what is the conversion factor that you need to consider in order to convert that unit to another. And this conversion factor is a dimensionless ratio. What does it mean by dimensionless ratio? That means that it doesn't have any unit. So it's just a number. And for instance, you need to memorize a simple one. For instance, like how to change from degree Celsius to Fahrenheit, something like this. You need to just remember it a little bit. For example here, and I already mentioned during the first class, where for example, I really want you to also do the same example as I given here, and write it on a piece of paper and scan it and upload it in the Putrablast, because it's one of the way to indicate whether you have attended the class and go through the notes or not. So I hope that after I give all the example in this lecture, you will be able to do the same. Just write down and try to understand a little bit more, and then scan your work and upload in the Putrablast. So if a plane travel at twice the speed of sound, assume the speed of sound is 1100 feet per second, how fast is it going in miles per hour? So the thing here is it's in English unit. You can see here feet per second, feet, and this is SI unit, so it's a combination of both. So the question want you to convert this to miles per hour, and there are few things that you need to also consider in this question, where the plane travel at twice the speed of sound. That means the speed of sound is this, so the plane is twice. This 1100 feet per second need to be multiplied by 2, because the plane travel at twice the speed of sound. And then after that we can do the conversion. Let's just do the conversion here. What I'm going to do, normally I'm just going to draw a very long line here, and then we're going to start with the first is that twice. So I'm just going to put 2 here to multiply by, and then 1100. We just going to do it properly so that we're not going to left any kind of unit, and then feet per second. So we want to convert this into miles per hour, and this is based on the conversion factor that I refer to in the conversion table. It's not 1 this is 1 miles is equals to 5,280 feet. And then so we try to start with the feet first, and then with the minute, with the second, and then for second, 60 seconds equals to 1 minute, and 1 minute, 60 minutes equals to 1 hour. So what we need to do is to cancel out this unit. Feet, we already cancel this like this, and for second is here, for minutes here. So after we have done this, the final answer will be 1,500 miles per hour. So this is the way to do it.